Probably. We'll see how it goes. So what we're starting off with today is these two theorems here. Congruent supplements theorem. If two angles are supplementary to the same angle or to congruent angles, then they are congruent. So what that means, if angle 1 and angle 2 are supplementary, angle 1 and angle 2 add together to be 180. And we also know that 2 and 3 are supplementary. So what we've said is that the measure of angle 1 plus the measure of angle 2 is equal to 180. We've also said that the measure of angle 3 plus the measure of angle 2 is equal to 180. So what that means is that, well, the measure of angle 1 is going to equal the measure of angle 3, which is really just saying 1 is congruent to angle 3. Well, if we look at it, if I said the measure of angle 1 is 89 degrees, well, the measure of angle 2 would have to be what? So that the measure of angle 1 plus the measure of angle 2 equals 180. So 89, or 180 minus 89 would be 91. Because we can say that 89 plus 91 is equal to. Now, if we also said that the measure of angle 2 plus the measure of angle 3 is equal to 180, well, what's angle 2? So we're saying 91 plus the measure of angle 3 is equal to 180. What does the measure of angle 3 have to be? So angle 1 is congruent to angle 3. That's all that's saying. Because if two angles are complementary or supplementary angles, two angles are supplementary angles to the same angle, 1 and 2, 2 and 3, same angle, then they're going to be congruent. They have to be. Congruent complements theorem. Well, if two angles are complementary to the same angle, they must be congruent. So it's the exact same statements, except instead of them being equal to 180, they will be equal to what? 90, because complement is 90. Yes? Are we good on keeping those two straight? Yes? Awesome, because those are two that normally it's easy to get them flipped if we're not thinking about it. Complement is 90, supplement is 180. The main way I try to keep them straight in my head is compliment. You're just giving someone a compliment, kind of saying, hey, we're only going about halfway. Supplement, you're actually helping out. You're going all the way. Compliment is kind of part way. Supplement, you're actually helping out. You're going a whole 180 degrees. At least that's the way I kind of try to keep it straight in my head. Have that there. Now, proofs. We've talked about two-column proofs. Because it's, well, essentially exactly what it means. It's two columns. One side's our statement, other is our reasoning. The other type of proof is a flowchart proof. I like flowchart proofs a little bit better. They're a little bit, well, they're a little bit more easy to understand because it's a flow of how our thought process is going. What leads to what? Now, with any proof, we always start with what? The given. So our first bubble will be the given information. Angle 1 and angle 2 are right angles. Okay. Now what are we wanting to prove? 1 is congruent to 2, yes? Well, if two angles are congruent, they have the same what? Measure, right? So I need to be able to show that the measures are the same, yes? So they would both be equal to 90 degrees, yes? Because if they're both right angles, Means they're both equal to 90 degrees. And that right there is why I like this. Because in 2-column, we would just have angle 1 and angle 2 are right angles. Right below it, we have this, and then just continue on down the list. But really what we're saying is, kind of drawing the arrow, because they're right angles, it means this. It leads from here to here. We're showing what goes where. Well, since they're both equal to 90, we can say that they are equal to each other, which means that they are congruent. The only downside to flowchart proofs is some of the bigger ones we get, it takes up a ton of space trying to write it out. Because if you've ever done, it's not a Venn diagram, but essentially a bubble chart for English, your key topic, and then branching off to subtopics, and those subtopics, it gets very big very fast. Okay. Oh, I probably, yep, when I threw it through the printer, it probably had it upside down. That's my bad, or my fault. So, we always start with the given information. Given information. Would be the mouse right there. We start with the given information. Now, you're probably wondering why we skipped those middle spots. Because we have angle 1 and angle 2 are supplementary, given. We don't go to the next one, then we jump down here. Angle 1 and angle 3 are supplementary angles. Because really, if we set this up, you don't have to write this down. 1 and I think it's 3 are sup. And then I think it said 2 and 3. Upside down, there we go. Yeah, so 1 and 2 are supplementary. 1 and 3 are supplementary angles. We would actually have it split because if we come back over here, well, if 1 and 2 are supplementary angles, they do what? By definition of supplementary angles, they add together to be 180. So 1 and 3 add together to be 180 degrees. So because they're supplementary angles, it means they add together to be 180. We got that copy down. Now, on the flow chart, because really this is saying that measure of angle 1 plus the measure of angle 2 equals 180. Measure of angle 1 plus the measure of angle 3 equals 180. And we would have these separate because, again, they're not connected to each other, are they? Well, not yet, because of the fact that 1 and 2 are supplementary. It means they add together to be 180. Because 1 and 3 are supplementary, it means that they add together to be 180 degrees. Well, wrong direction. Well, but don't both of these equal 180? So what can we do? We could set them equal to each other. And that's our transitive property of quality. So I drew it up on the whiteboard, but really at this point, we're taking these two statements, because now we're taking both of them, putting them together. We're using both statements to make the next part, that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. And that's really how these flowcharts look, is that we start out with our individual statements, what's given, go to the next, go to the next. What is leading where? We're essentially drawing the path out. Well, and again, we're trying to say what? That 2 is congruent to 3. Should be 1. So we do have the measure of angle 1 in both statements, yes? It's just a number, right? So we can do what to get rid of it on both sides? We can subtract it. We can use the subtraction property of equality to subtract the measure of angle 1 from both sides, whatever it is, to really say that the measure of angle 2 is equal to the measure of angle 3. And well, if their measures are equal, it means that they are congruent. And that's it. So the real positive with flowchart proofs is it gives us a very definite way to organize our thoughts. What is leading to what? What follows from what? So when we talked about yesterday that the ray MN is the angle bisector, because we'd start off with it being the first bubble, arrow from it, that the two angles are congruent to each other because of the definition of angle bisector. From there, actually, let me just draw it out. Because we have angle bisector. Well, that means that the two angles would be congruent. Yes? And really from this here, it means that the angle measures would be equal. As y'all remember walking through that, actually, yeah, that was yesterday. And then that's as far as we took it, wasn't it? We couldn't take it any further. But then we went and defined that the big angle is equal to the sum of its two parts because of our angle addition postulate. Well, I know that these are equal, so I could say that my next statement is combining these two to get me the big is equal to the same part plus the same part, other part, which means we had 2 times the part equals the big angle. So we can actually start seeing where do they interact? How do the statements interact with each other? Because when we have the 2-column proof, it's just all straight down the page. There's no real way that we see how is it all working together, where are we grabbing from each part. So they do have there are differences, because even the one we did yesterday, it wouldn't take up as much space as this one does. But this one here, we can see how it flows a little bit better. Flow chart flows. Okay. I'll just say this, don't get me and my dad in the same room for too long. Copy and complete the flowchart proof. Then, write a two-column proof. So, well, we start off with the given. AB and BC are perpendicular. DC and BC are perpendicular. Well, and we want to prove that they are congruent, yes? I feel like there should be more than one step, but really we're saying that angle B is equal to 90 and angle C is equal to 90 degrees. Okay, yeah. Essentially, they're saying the same thing, or really angle B and angle C are both right angles. Since they both have the same measure, it means that they are congruent. And that's it. So this is really just, if I can write, definition of congruent angles. Now, some might make a nitpick about that, the fact that if you put the definition of congruency angles, I'm not going to make a nitpick about that. All right, so let's leave those away for now. Thank you. Now, if you wanted to, because in a flowchart or in a flowchart proof, we would really start off with AB is perpendicular to BC, and DC is perpendicular to BC because of given. That's what we're told to us, yes? Well, since they're perpendicular, well, we can say that angle B equals 90. Angle C is equal to 90 degrees. Definition of perpendicular lines. Well, we saw there they just went straight to saying B is congruent to C. Measure of angle B is, or just angle B is congruent to angle C, yes? Would it be wrong if I put here 3, because that really should be measure, that the measure of angle B is equal to the measure of angle C, and then saying that angle B is congruent to angle C? Well, no, I just added that extra step is of our transitive property of equality, and then just definition of congruent angles. This saying the exact same thing. I just added that extra step of setting them equal to each other. But that's it. Questions on this here? Use the given flowchart proof to write a 2-column proof. Going from flowchart to 2-column is actually easy to do, because what do we always start with? Well, actually, we already did it. You even realize that. So, I got ahead of myself, because we just actually did that. We didn't actually need to fill that in. But if you notice, because when we go from the flowchart proof, well, we start with the given. Then what does it say next? Well, the angles are equal to 90, or that they're right angles, and they're congruent. Yeah. Now, we will have another one here. Use the given 2-column proof to write a flowchart proof that proves that 2 supplementary angles to the same angle are congruent. So we want to write a paragraph, or not a paragraph, a flowchart proof of this. So we'll do that. We can do this. I'm going to do it on a separate page so it's not all up here. But luckily, that's fine because y'all have it right in front of you, yes? And we'll use some shorthand notation. I want to fix that. What is the first 2 statements that are given? So before we start doing circles, let's just say angle 1 and angle 2 are supplementary angles. Why? Given. And we really write the reason below the bubble. Now we also know that angle 3 and angle 2 are supplementary angles. And that is given. Well, since these are supplementary angles, it means they do what? Measure of angle 1 plus the measure of angle 2 is what? 180. And that's by the definition of sup angles. That also means down here, 2 plus the measure of angle 3 is equal to 180. Definition of sup angles. We can bring these 2 together to really say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. The property of equality. Since they both have the measure of angle 2, and then we can subtract it from both sides to really say that the measure of angle 1 is equal to the measure of angle 3. And well, last but not least, we can say that angle 1 is congruent to angle 3 by the definition of congruent angles. Questions on any of this here? We good with this? Okay. That brings us to the last thing, or the last part of these note sheets. Linear pairs, linear pair postulate. If two angles form a linear pair, then they are supplementary. 1 and 2 form a linear pair, so 1 and 2 are supplementary. And the measure of angle 1 plus the measure of angle 2 is equal to 180. Vertical angles are congruent. So two angles are vertical angles, that means they have the same measure. Now, both of these are actually quite helpful. Because looking at this here, where these two lines cross, using these two formulas, or these not formulas, these two theorems, a theorem and a postulate, I can find these four angles only given one. Because if we look at this here, and I fill in the fact that the measure of angle 1 is 117 degrees. And we want to find the measure of angle 2, measure of angle 3, and the measure of angle 4. What's one of these that we know right off the bat? So 1 is 117, yes? What other angle do we know for sure? 3, because 1 and 3 are what? Congruent. They are vertical angles, so they are congruent. So what's the measure of angle 3? 117 degrees. Okay. Now we'll have to do a little calculations to find the next one. But how can we find 4 or 2? One more time. Exactly, because 1 and 4 are a linear pair. They make a straight line, yes? So 1 plus 4 should equal 180. So the measure of angle 4 plus 117 is equal to 180, or really we can just subtract 117 from 180 to find out the measure of angle 4 is 63 degrees. Because 2 and 4 are what? Vertical angles. And that's it. So even though I wasn't given all 4 or 2 angles, if I know one where two lines cross, I can find the other vertical angle with it. Linear pair, vertical angle. And we're done. Now if we look at this here, the measure of angle 2 is 59 degrees. So the measure of angle 4 we're saying is 59 degrees. Because 2 and 4 are vertical angles. Yes? Now, 59. What do we know about 1 and 4, 1 and 2, 2 and 3, or 3 and 4? They're what? They're a linear pair. They make a straight line, yes? So they should add together to be 180. Or I can take 180 and subtract 59. And this would give us so the other two angles are 121 degrees. And that's it. Questions on this here? Angle 4 is 88 degrees. What's angle 2? To find angle 1, we're going to do what? 180 minus. So we're just taking 180 and minusing 88 and getting 92. Questions on this here? Find the value of x. So here they're not asking for the angle measure, we're just wanting to know the value of x. So what do I know about 3x plus 1 and 148? They're congruent, yes? Because those two angles should have the same value. So really we're saying what? 3x plus 1 is equal to 148 degrees. Because TPS and QPR are vertical angles, it means their measures are going to be the same. So we can set them equal to each other. And what do we need to do first to find the value of x? We can subtract 1 from both sides. Because 1 minus 1 will be 0, leaving us with just 3x. 148 minus 1 is 147. And then we would both sides by 3. So it works out that the value of x is 49. Questions on this here? Are you ready to look at the last one? Find the value of w. Well, we know that these two are congruent. They're vertical angles. So 5w plus 3 is going to equal, and then we would minus 3 from both sides, which will tell us that 5w is equal to divide both sides by 5. That's it. Now, even if they didn't give us an expression, so 5w plus 3 and 98, because if they told us this was like 4w plus 7, does it really matter? No, because those two would be equal. We'll just set them equal and solve. It doesn't really change anything. Now, there are actually 3 types of proofs. We covered 2-column, because we talked about 2-column sum today, and we talked about it yesterday and Friday. Well, all this week so far and Friday, we talked about 2-column proofs. The one we saw today was a flowchart proof. And the last is actually a paragraph proof, and it literally means we write it as a paragraph. We write it as a paragraph. And a lot of research journals or a lot of research papers are actually written in paragraph. They're actually written like a paper. And you can read them like a paper. They'll have some formulas and equations thrown in, but they literally look like a paper. And that is it. That is all we're doing for 2.6. So we are done with chapter 2.